At the bottom of the page, you can put marked by and your name. No, you don't need to. You're marking your own. I know who's marking. Really? Really? Wow, I got you there. Okay. Well, I'm going to introduce you, Gabor, to my favorite student. Here's my favorite student. Her name is Anne Serkey. She gets everything right, always. Think about it. Some of you will get the joke, some of you way over your head. Expressed in scientific notation, 1 mark each. 1.23 times 10 to, just got the joke there, 5. Half mark for the 1.23, half mark for the times 10 to the 5th. So wrong exponent, you lose a half mark. 1 times 10 to the negative 3 or 4? 4. Half mark for the 1, half mark for the times 10 to the negative 4. 2.5 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. Yes? If I make a mistake, let me know. I never make mistakes. Missed that. Okay. 7.8062. I've got to write those because I guess they're all significant. Times 10 to the 1, 2, 3, 7 is correct. Perform the following operations on your calculator. Check. Use the correct number of sig figs and express your answer in scientific notation. Well, 2 sig figs, not 1. 2 sig figs. I'm going to go to 2 sig figs. Now I go to my calculator. 5 scientific notation button 4 times 1.6 scientific notation button negative 3. You'll notice I didn't bother typing the 5.0. Will the 0.0 make a difference to what my calculator displays at all? Then I'm not going to type extra stuff just to make you all feel better. I got 80. I'll write that here. They want my answer in scientific notation. Why would this be wrong? Yeah, 2 sig figs, so I guess 8.0. Half mark for the 8.0, half mark for the times 10 to the 1. Mr. Dewick, if I didn't put a 1 because there's always an implied invisible 1 there, is that okay? Yes, it is. I'm fine with that. But I'll put the 1 there because for some of you, that just creeps you out with it not being there. 2 sig figs, 2 sig figs. Again, I'm going to go to 2 sig figs. 1.5 scientific notation negative 5 divided by 3.5 scientific notation 8. Do y'all get 4.3 times 10 to the negative 14? Yes? Pause for a second, put your pencils down, look up. The reason I showed you all how to use your scientific notation button, if you don't use that button, if you type this out the long way, this is how you would have to type it out. You would have to go bracket 1.5 times 10 to the power of negative 5, close off the top, divided by bracket 3.5 times 10 to the power of 8, close off the bottom. I'm going to argue this line here, way less typing and kind of easier to make sense of and read in my mind than this line here. Yeah, you'll get the same answer, but you'll just do way, way more typing. So that's really why I pushed you to learn where your scientific notation button was. Number 3, here was your curveball. I haven't done scientific notation and adding. Remember I told you that for adding, it's the number of, not sig figs, decimal places. I think the first thing that I need to do is I need to write out these numbers. 0.00075 plus 0.00013. That's what it's going to be. Good morning, good morning. So glad you made it. Speaking of zeros. Oh, no, just kidding. Or am I? So that means you're cutting it too close. I will never accept train as an excuse, because also kids lie all the time. I've heard that train BS for 24 years, and I know that many times they're just lying because I have no way of confirming it. And it also just means you're cutting it too close. You will never hear me say, oh, I'm late for work because there was a train. I aim to be here for 8:15. Welcome to being treated like an adult. Get out your take-home quiz. We're going to mark it. So if I add this, I get 0.00075 plus 0.000013. My calculator gives me an answer back in scientific notation, but I can translate that as 0.000764. How many decimal places is this first one? How many decimal places is this second one? How many decimal places am I going to go to? 5. So I guess, and now I need to write that in scientific notation. Half mark for the 7.6, half mark for the times 10 to the negative 4. By the way, Maxine, did you see what I actually did? I wasn't sure how to do this, so I turned it into a question I already knew how to do. Useful trick. We'll be doing that all year long. Many times you'll hear me say, well, we can memorize a whole new procedure, or what if we turn it into something we already know how to do? Less memorizing, and I can do that in my sleep. And yeah, turn the page. It doesn't say to write in scientific notation. We're multiplying. So 2 sig figs, 2 sig figs. I'm going to go to 2 sig figs. 0.15 times 0.0016. I get an answer in scientific notation. So you could write 2.4 times 10 to the negative 4, and that is to 2 sig figs. Or you could write 0.00024. Either of those is fine. For these ones, all or nothing, no half marks. 40.0, how many sig figs is that? Spoiler, not 2. How many sig figs is 40.0? 3. How many sig figs is 30.00? I'm going to go to 3 sig figs, not 2. So this is going to end up being 40 divided by 30. How many sig figs? 3. 1.33. Not 1.3, not 1.333. Is that wrong? No, I'm right. Oh, I hate it when that happens. Actually, that's never happened to me because I do everything perfect. I never make mistakes. Yeah. If you wrote it in scientific notation and you did that, you're weird and kind of creepy, but it's not mathematically wrong, so I'll live with it. That just explains so much about you right there. 3 sig figs, 2 sig figs. I'm going to go to 3. By the way, you see, scientific notation, counting the number of sig figs is nice and easy. It's tougher when it's in standard form. Okay. 5.15 scientific notation button, negative 5, divided by 6 scientific notation button, negative 7. And I get 85.8. Making sure I didn't make a typo. 2 sig figs. I guess I have to write 86 or 8.6 times 10 to the 1 if you are so inclined and feel like writing it in scientific notation, even though you didn't need to.
Sorry.
Oh, you're not sorry yet? Wait till I'm done. Adding and subtracting. Now I have to flip gears. It's a completely different rule. Decimal places. So I almost went 3 sig figs. No, not 3 sig figs. 2 decimal places. 3 decimal places. I'm going to go to 2 decimal places. The second decimal place is that 8. Is that 8 going to stay an 8 or become a 9? So you're saying 9? No, nothing. Is that right? Is it 13.18? Is that correct? I haven't made a typo, have I? Which is to 4 sig figs, but who can? It's decimal places. Okay. Question, Mesa? You sat in the back row. Here. Better? Okay, because I do care. 3 decimal places, 1 decimal place. So it's going to be 615.824 minus 55.2. 1 decimal place. I'm going to go to the 6. Is that 6 going to stay a 6 or become a 7? So 560.6. Did you write these in scientific notation at all, Mesa, or not? You didn't? Okay, so you're inconsistent? Of course you are. Can you give yourself a lovely score on the top page out of 12, please? Write a little score right there, please. So as I mentioned to you, but I'll say it again because you're teenagers and I need to repeat myself. You're teenagers and I need to repeat myself. Sometimes because you're teenagers, I need to repeat myself. So I did that. This is not the easiest method to do what we call unit conversion or dimensional analysis. But if you wrap your brain around it, it's really, really, really handy. Who's in Chem 11 this semester? You'll be doing this lesson yesterday or today, or you might have, ready to get it? So for you, it'll be kind of a repeat. Here's the first thought puzzle. If A times B equals A, what must B equal? If 5 times something equals 5, what number must be there? 1. So the first thing, which may be Captain Obvious, but it's actually terribly profound, if I multiply by 1, I'll always get the same answer. The method that I'm going to teach you is going to involve multiplying by 1 because we don't want to change our value. We want to make our value look different units, but it still has to have the same value. But I can write 1 in many, many different ways. Is that a 1? Yes? Is that a 1? Yes? Is that a 1? Let's see. Those would cancel. Those would cancel. Those would cancel. In a fraction of everything cancels. Yeah, that's a 1. That's a 1. Here's the weird one. "60 minutes over 1 hour. That's a 1 because that is also the same thing divided by the same thing. It looks different, but I'm telling you, 60 minutes and 1 hour are identical quantities. And when you divide identical quantities by themselves, you get 1. And this is the key idea. Oh, is this equal to 1? 4/4 over 1 loonie? Yeah. Yes, it is. We call this a conversion factor or conversion fraction. And yes, we're going to be using fractions, the math F word, not the F word you're thinking of. We're going to be using fractions and conversion factors. By doing that, you can dramatically reduce your memorization. You can drop it to near 0. Or you can drop it to stuff, Jay, that you've already memorized without realizing that you've already memorized. As an example, how many minutes are in an hour? You all have kind of memorized. How many seconds are in a minute? How many hours in a day? Those are conversion factors that you've inadvertently memorized just by growing up. We'll tie into that. But otherwise, we're not going to try and memorize stuff. You want the back of your green sheet, by the way? All the metric prefixes handy. Okay. So, first concept, multiplying by 1 doesn't change your answer. Second concept, any fraction equals 1 as long as the numerator, top, and the denominator, bottom, have the same value. We can use this for something called dimensional analysis or unit conversion. We're going to multiply by a series of fractional ones until we end up with only the units that we want left behind. Since we're multiplying by 1, our answer won't actually change. What we are going to do is make it look different. Is that okay, Hannah? Okay. We call these strange looking ones conversion factors. As an example, if I know that 1 kilogram equals 2.2 pounds, it says convert 12 pounds to kilograms. All right. You may know how to do this. I'm going to give you, again, Alexis, a generic way that will work all the time. And I want to start out with an easy procedure that we can do every time. One of the things you're going to find out from me as a teacher, I'm big on writing something down to start out. I figure if I've written something down, Cam, I feel better. I'm no longer stressed. Can you take the hoodie off? By the way? Again, I just can't tell if headphones are in. It's a personal peeve of mine, that's all. So, how do I start any conversion factor question, any dimensional analysis question? I always start out by writing down what they gave me. Convert what? I'm going to write 12 pounds. You know what? I probably don't even need to put the apostrophe s, 12 pounds. Have I written something down? Am I more relaxed? Do I feel better? Have the odds of success gone up? Yes. So I always, you give me a unit conversion, my first step, I write down what they gave me, which I'm going to pretend is something all of you can accomplish. Now, look up, don't write this down. This is a fraction. Anything is a fraction because it's always technically over 1. Can we agree on that? I'm not going to put that in anymore. What I am going to say is that 12 pounds is on the top. Write a times sign, draw a fraction bar. I want pounds to cancel. It's on the top in my first fraction. Where do I want pounds to go in my second fraction if I want it to cancel? On the 2.2 pounds, because that's my conversion factor. What's going to go on the top? 1 kilogram. Notice, look up. Pounds cancels. What are the only units that are still sitting around? This is going to be kilograms. This answers for you automatically. Do I divide by 2.2 or multiply by 2.2? Because that's really the question, Kayla, most kids have. Is, what do I do with it? Where is that 2.2, on the top or on the bottom? It means divide. It's going to be 12 times 1 divided by 2.2. Go. Oh, do I really need to times by 1 or will that change anything? So spoiler, I'm going to ignore the ones. It's going to be 12 divided by 2.2. 12 pounds is 5.45454545 kilograms. I guess technically I should go to 2 sig figs because of the 12 and the 2.2. So 5.5 kilograms. What if I want to convert 64 kilograms to pounds? I'm going to write down what they gave me. Victor, have I written something down? I'm more relaxed. I feel better. I'm going to realize that's technically a fraction. I'm going to multiply by a conversion factor. What do I want to get rid of, Wolf? Kilograms. Where is kilograms right now? On the... Where am I going to put it in my conversion factor? On the... Yes. How many kilograms? I guess my conversion factor says 1 kilograms is 2.2 pounds. Notice kilograms on the top and on the bottom, it cancels like x squared on the top and x squared on the bottom. What are the only units left behind, Wolf, my friend? Where is that 2.2? It's on the top. I'm going to go 64 times 2.2. And I get 140.8. technically I should go to 2 sig figs, so I'm going to go like this. 140.8 equals 140 kilograms, and there I've got my long answer and my sig fig rounding off, so I know what the heck I did. Sorry? Oh, it's pounds, Mr. Dewick. You got the wrong units there. Thank you. You caught me in a mistake. You get a candy. You can use this with metric prefixes as well. So convert the following. 12, what's capital M? 12 megagrams to grams. Okay. Anybody want to guess what the first thing I'm going to do is? Write down what they gave me. I'm going to write down 12 megagrams. I'm going to multiply by a conversion factor. What do I want to get rid of? Megagrams. Where is the megagrams going to go in my second fraction then? Now, what's the conversion factor? Find on your green sheet the power of 10 that goes with mega. 10 to the 6? That goes where the metric prefix isn't, which in this case is on the top. If the mega was on the top, the 10 to the 6 would have gone on the bottom. It goes where the metric prefix isn't. Don't try and memorize, oh, it goes on the top, or oh, it goes on the bottom. It'll depend on the question. But the power of 10 from your green sheet, this is 10 to the 6th as an abreve. The 10 to the 6th as a number goes where the abreve isn't. Where is that 10 to the 6th? On the top or on the bottom? So I'm going to times by 10 to the 6th or divide by 10 to the 6th. Now, this looks like scientific notation because of the power of 10. It's not. I'm not going to use my scientific notation button. I'm going to go 12 times 10 power button 6. And when I do that, I get a 12 with 6 zeros. Would it be less work to write that in scientific notation or to write it out in standard form? I think I'm going to write this in scientific notation. So I'm, like Mesa, going to choose to go 1.2 times 10 to the 7th grams. You know what, Mr. Dewick? You're moving into your next question. Let's do it here. 1.2 times 10 to the 7th grams. 12 megagrams is 1.2 times 10 to the 7th grams. I call these one-step questions because one step. You'll see in part B, we'll do two-step questions in a second. Number 2, convert 13.6 amps to milliamps. Okay. Anybody want to guess what I'm going to do first? Going to write down what they gave me. 13.6 amps. I guess I want amps to cancel. Where is it going to go in my next fraction? On the bottom, you say. I guess that means that the milliamps is going to go on the top, because that's what I want left behind. Milli on your formula sheet. 10 to the? Where does the 10 to the negative 3 go? Where the milli isn't. In this case, on the bottom. If it's on the bottom, am I going to times by 10 to the negative 3 or divide by 10 to the negative 3? On your calculator, 13.6 divided by 10 to the negative 3. Now, this is a complicated, not the easiest method, but if you understand this, it just takes care of itself and you don't need to memorize any procedure. And I get 13,600. Is it less work to write that in scientific notation or to write it in standard form? I think it's less work to write it in standard form. I'm going to write it as 13,600. Milliamps, which I already have there. Eliana, let's do a two-step question. What do I mean by a two-step question? They want me to go from kilograms to, Eliana, what's that funky symbol there in abbrev for? Micro. I'm going to do it 2 steps. Here's what I'm going to do. I'm going to get rid of kilo first and end up just in grams. And then I'm going to go from grams to micro. Anybody want to guess what I'm going to do first? Write down what they gave me. So 13.6 kilograms. Again, first thing I got to do is get rid of the kilo. Where's the kilograms going to go if I want it to cancel? Down here, Eliana, kilo is 10 to the what? The 10 to the third is going to go where the kilo isn't, which in this case is on the top. Now, if I stopped there, I would be in grams. Do I want to be in grams? No, I want to be in micrograms. So I guess in my next fraction, I need to cancel out grams. Where is grams right now? On the top. So where is it going to go in my next fraction? On the... And you know what's going to go on the top? What I want to be left with, micrograms. Eliana, micro, 10 to the what? Where is the 10 to the negative 6 going to go? Where the micro isn't. Which in this case is where, Eliana? On the... Sorry? On the bottom. Yep. So, grams cancels. And all that's left behind is micrograms. See it? I guess it's going to be 13.6 times 10 to the 3 divided by 10 to the negative 6. Let's go on. Make sure you're trying this on your calculator, because if you can't do these on your calculator, it does you no good. Right, Kayla? And if you aren't able to do these on your calculator, now is your chance to quickly shoot your hand up and I'll help you. Or if you foolishly don't have a calculator here yet, or you didn't bring one for some obscure reason because you know it was in your locker and you didn't want to be late for class or something like that. I got an answer in scientific notation. I'm willing to bet most of you did, because probably your calculators can't display that many digits. Did you all get 1.36 times 10 to the 10th? Also, you may notice for unit conversions, we're ignoring sig figs. We're assuming that these are actually not 1 sig fig. They're it's not 10 to the third. It's 10.000000000 to the third, because we've defined it that way. So I don't say, oh, 1 sig fig. Ooh. What's the lowercase n? Nanoliters to megaliters. 2 steps. How do I know it's 2 steps? I'm going from one metric prefix to another metric prefix. Step 1, get rid of nano. Step 2, bring in mega. Here we go. Paige, what's the first thing I'm going to do? I like that. That part I can remember to do. Oh, look up. I will always, when I write a lowercase l, write it in cursive like that. Why won't I write a lowercase l like that? Looks like a 1. Also, for what it's worth, I'll write a 7. I'll always put a little line through it so those of you in the back can tell it's not a 1. And that's a 2. That's a Z. Just things I'll do to help you out, okay? What's going to go in the bottom? Nanoliters, because I want the NLs to cancel. On the top is going to go just plain old liters, except this is not a 1. I need to bring in my conversion factor. Nano, 10 to the what? 10 to the negative 9. Where is the 10 to the negative 9 going to go? Not where the nano is, where the nano is not. And if I stopped there, that would be liters. But let's keep going. Now I want to introduce megaliters. What's going to go on the bottom of this conversion factor? What do I need to get rid of? Good. I need to bring in megaliters. Mega, 10 to the 6th, I think. Where's that going to go? So in this case, on the, yes. So it's going to be 2,000 times 10 to the negative 9 divided by 10 to the 6th, which is what? I think you're going to get an answer in scientific notation. I think it's going to be a small number, like a 10 to the negative something. 2 times 10 to negative 12? Megaliters. If you're getting something a bit different, or especially if your exponent is different, I got a negative 11 or a negative 13, let me know. I can probably figure out what. Okay, let me come look at your calculator. Let's try number 5. I'll try it here. Some of you already worked ahead. So it's going to be 342.5 kilometers. I want kilometers to cancel, so just plain old meters. The 10 to the 3rd goes where the kilo isn't. And then I want to get rid of meters, bring in millimeters, and milli is 10 to the negative 3, and that goes where the milli isn't, which in this case is on the bottom. So I'm going to end up, I think, with a pretty big number. And I get 3425 and then 5 zeros, is that right? I think I'm going to write that in scientific notation. You can write 3425 and 5 zeros. I'm going to write 3.425 times 10 to the 8th. Units, millimeters. Units matter. I will take marks off if you have incorrect or missing units on your final answer. In fact, a good habit before you ever hand in a test, scan your test, make sure all of your final answers have correct units. Turn the page. How many of you got that all right on your own, by the way? Okay, it's tricky. Put your pencils down, look up. This trick of using a conversion factor, a fraction, can help you get away with memorizing way, way less. As an example, how many seconds in 1 week? First of all, does anybody know how many seconds there are in 1 week? Anybody want to guess what I'm going to do first? Write down what they, not what they want, what they gave me. 1 week. I'm going to abbreviate week with a W. What can you all break weeks into? What have you memorized? 1 week is the same as what? All of you have memorized that it's 7 days. So you know what? Let's use a conversion factor. Where do I want weeks to go in my next fraction? Days on the top. And you've all told me 7 days is 1 week. So I guess the 7 goes next to the days. And the 1 goes, by the way, you could also have gone 14 days is 2 weeks or 21 days is 3 weeks, but why? Do yourself a favor. If we stopped there, that would be days. What can I break days into? Hours, you say. You've all memorized that? Great. So I want days on the bottom, hours on the top. How many hours is how many days? You can go 24 hours is 1 day. If you want to be weird, you can go 48 is 2. But yeah, 24 hours, 1 day. Does anyone by chance know how many seconds there are in an hour? Because we're trying to get to seconds. No? Then what can I break hours into? Minutes, you say. Have you memorized this just because, like, growing up? Well, that's cool. What kind of minutes? What's the conversion factor between minutes and hours? How many minutes is how many hours? 60 minutes is? Well, so I can get hours to cancel. Where is hours going to go? Well, since it was on the top originally, it's going to go on the bottom. Why can't I use M for my abbrev for minutes? Okay. Why can't I use MI as my abbrev for minutes? Miles, story, stupid US. So my abbrev for minutes is going to be MIN. And you're telling me 60 minutes, 1 hour? Cool. What do I want to end up with? Seconds. Anybody have a conversion factor for minutes and seconds? Oh, really? So minutes on the bottom, you're telling me 1 minute is 60 S's. And you'll notice all my units have canceled. The only units left behind are seconds. And anything on the top means multiply. Anything on the bottom means divide. And I ignore the ones. This answers the question, Cam, that kids always ask me, Mr. Dewick, do I times by 60 or divide by 60? I don't know. I've never memorized it. I don't need to. I derive it from my conversion factor. I think in this case it's times. It's going to be 7 times 24 times 60 times 60. Did I miss any? No. 604, 800? I don't need to memorize it. I can derive it. I was in a second-year calculus class. Seconds. Odetta, you had your hand up first. Other people blurted it out, but you were going to say, I owe you a candy. Make sure I don't forget. Seconds. I was in a second-year calculus class, and we were doing something called mixture problems. It goes something like this. You have a 1,000-liter tank. The 1,000-liter tank is 80% full, so 800 liters, and it's 80% full of a 60% mixture. It's draining at 3 liters a minute. You're pouring in at 1 liter a minute, a 75% mixture. After 20 minutes, what percent of the tank is the mixture? Which is a very complicated question, and you can do it in calculus in 2 lines. And I blanked on the test. I could not remember how to do it. But I was able to set up, I think it was about a 14 or 15 long fraction chain, and I got the right answer because all my units ended up canceling. Oh, there you go. I got an answer and a percentage is what I was aiming for. And I remember my prof wrote a note, this is the easier way to do this. Yeah, I blanked. This can bail you out of a lot. Example 7, how many hours in 1 year? I'll ask, does anybody know how many hours are in 1 year? Because if you happen to have memorized that, you've got a shortcut. Have you memorized that? You both have memorized that? You have a shortcut. And that's great. I've never bothered, so I'm going to write down what they gave me. 1 year. Look up, don't write this down. Why can't I use a Y as my abbrev for years? Yards. Stupid Americans. So the correct abbrev for year actually comes from the word annually, lowercase a. If you write Y for year, I won't take marks off, but Kayla, I'll teach you how to abbrev properly because I'm a nerd that way. What can I break years into? Okay, I could go months, but then what would I go to after that? Days, but what's the problem? Are the number of months, days all the same? I'd be introducing error. Same with weeks, by the way. It's not exactly 52 weeks in a year. It's 52 and a bit. So I think days. How many days are in a year? Now what? Oh, I can go from days to hours? Great, 2 lines. Days, hours, 24 goes next to hours, 1 goes next to day. And I guess that 365 and that 24, since they're on the top, Rob, I'm going to multiply. And we'll see if it is, what do you say, 8,760? I'll be impressed. You've seriously earned some good nerd cred with me there. 8,760. How many seconds in a year? I don't know. Now, if you're a fan of the musical Rent, there is actually a song in there. It's a catchy song, and the chorus tells you how many minutes are in a year, and so you may have that conversion factor, which means you could go straight from years to minutes to seconds, 2 steps. But I'm going to assume most of you haven't heard the song from Rent, so I'm going to write down what they gave me. 1 year. What can I change years into? What can I change years into if I'm paying attention and looking at questions that I've already done? What could I go straight to if I was paying attention and being clever and noticing that I may have already created a conversion factor that I can jump to? Hours, you say? Why not? 8,761. Saved ourselves a couple of steps. How many seconds are in an hour? Has anybody noticed the pattern? How many seconds are in an hour? It's 60 times 60. It's 3,600. Now, if you don't memorize that, you can do it in 2 steps. But if you're lazy like me, you may have noticed that, or you may even be able to go with 60 times 60 in your head. So I'm going to go like this. Hours, seconds. There's 3,600 seconds in an hour, because I happen, Hannah, to know that. How many seconds in 1 year? I get 31, 21, and then 2,000. So if I put in the commas, every year is a little more than 31 million seconds. Is that wrong? Mr. Dewick made a typo. You get 31536. That looks a little better. So every year is about 31.5 million seconds, roughly. This is my unit conversion method because it works, Tyson, for everything. Good stretch? Yeah, stretch it out. I've been talking a while. There may be easier methods out there for going metric prefixes. There is, but it won't work for this. There may be easier ways to do this, but they won't work for metric. I like a one-size-fits-all, and I realize it's a bit complicated. So here is my conversion method. Step 1, I write down what they gave me, and I wrote as a 2-level fraction. Here's what I mean. I will never write something like this, 5 kilometers slanty fraction hours. I will write it as 5 kilometers over hours. We'll talk about an example like that in a bit. Look at the units and find a conversion factor with those units. If it's a metric prefix, it's on your green sheet. If the original units are on top, they will be in the where of the conversion factor. If the original units are on the bottom, they'll be on the top of the conversion factor. If it's a metric prefix, it goes where the letter isn't. So it goes where the mega or the kilo or the milli or the micro isn't. The 10 to the goes where it isn't. Cross out the units when done. It's a good way to check to see which units are left. If we have a table of conversion factors, I going to finish the lesson, Mr. Dewick? We're going to get close. This class ends when? Okay, let's do this. Pause here for a second. Hold on. Take a look at the sheet that I just gave you. I haven't quite finished off the lesson yet. So right now, you're capable of doing, I think, based on what I've taught you, all the way up to the letter N. I'm eventually going to assign the rest of it, but if you want to get a head start, you can start working on these. If you write medium small, you can do these right on the sheet. If you need to write large, you can do these on a separate piece of paper. Did I attach the answers? No. What I've done is I actually have a sheet showing all my steps. I'm going to send that out to you on Teams. I'll put it on my website, and I'll also print up a couple of copies so that you can borrow them. So for now, as we move into Flex, you got a few options. Flex is going to start in about 3 minutes. You can work on this. If you want to try and work ahead because you think you can figure these out, or you want to look at my solution key and see if you can figure it out, that's great. Some of you can do your quiz corrections. I'm going to try and get the quizzes entered during Flex and get them back to you during Flex. Or some of you are still missing a few assignments, or you probably have homework from another class that you can start working on as well, because we're kind of into the swing of the semester system. It moves pretty fast.